Hi, welcome to section 10.6, solving equations with radicals. Hopefully by the end of this, you all will be able to solve equations that contain radicals. All right, so let's talk about your toolbox. So just things to kind of remember as we're going through. The opposite operation of a root is an exponent. So for example, the opposite of square rooting is squaring. The opposite of cube rooting is cubing. All right, next thing might be new to you is the power rule. This says if both sides of an equation are raised to the same power, all solutions of the original equations are also solutions to the new equation. So basically, you can square both sides, or raise both sides to the third power, or raise both sides to the fourth power, whatever it is that you need to do. The only thing to keep in mind, though, is that you're squaring the whole side. So squaring the whole side means the whole side times itself however many times. It does not mean that you get to square the pieces. Okay, so just remember, like a plus b, that whole side squared, is not the same thing as a squared plus b squared. You've got to do a plus b times a plus b and actually distribute. So let's take a look at that. Okay, so how do you solve an equation with radicals? All right. First thing you're going to do is get a radical by itself. So you're going to get the square root by itself or the cube root by itself. Get whatever else is on the same side, get it on the other side, okay? Then you'll raise both sides of your equation by the same power to get rid of that radical. So if you got a square root, you're going to square both sides. If you've got a cube root, you're going to cube both sides. All right, sometimes you have to repeat this if necessary. So like if you have two different square roots and they didn't both kind of clear out when you raised it to the same power, sometimes you need to get a radical by itself again and repeat. Those are the longer ones. Most problems you don't have to do that, but occasionally you do. Okay, after all of that, you should just have a nice equation that has no radicals in it. So you're going to solve normally. Sometimes you have linear equations where you just kind of get your variable by itself and you add to both sides or subtract from both sides or multiply or divide both sides by the same thing and you kind of solve normally. Sometimes you're going to get quadratic equations and we'll solve those by factoring. Okay? The other thing that is actually really important to do is to check your solutions. The thing about squaring both sides or raising both sides to the third power is that sometimes you get extra solutions that are not solutions to the original equation. So you need to check your solutions and make sure they work. Those extra solutions are called extraneous solutions. All right, let's try a few, okay? The first one I have for you, in example 1a, is the square root of 5x plus 3, and then I have a plus 2 equals 0. All right, so first step should be get the square root by itself. So the only thing outside of the square root that we have on the same side is the plus 2. If I want to get rid of that, I'm going to do the opposite operation. The opposite of adding would be subtracting. So now I've got the square root of 5x plus 3 equals negative 2, and hopefully that negative gives you a chance to kind of stop and think, wait a second, can I have a square root equal to a negative number? No, we cannot do that. If it was a cube root, we could get a negative, but a square root always gives me positive values, so I'm never going to get a negative 2 no matter how hard I try. So I can stop here, not do any more work, because this is no solution. You cannot get a negative value from a square root. Okay? Let's try another one. And I promise this one will be longer and have a solution, okay? This one, I've got the square root of 5 minus x equals x plus 1. Great news, our radical is already by itself. We're ready to go. So if I want to undo the square root, what I'm going to do is square both sides. Because squaring and square rooting are opposite operations, they are going to undo each other. We're just going to have 5 minus x on the left side. On the right side, I have to square the whole side, not just pieces and parts. So just reminding you, that means that I'm doing x plus 1 times x plus 1. I'm multiplying that x plus 1, that whole side, by itself. So I do need to distribute. X times x is x squared. X times 1 is 1x. 1 times x is another 1x. And 1 times 1 is 1. At this point, just looking at it, I can tell that I have a quadratic equation that I need to solve. I know that because we have an x squared. So the highest power is 2. It's a quadratic. So how do I solve a quadratic equation? I use factoring. So to solve by factoring, I need to get everything on the same side. Then I'm going to factor it. Then I set each factor equal to 0 and solve those little equations. And then I'm going to check my answers at the end. Okay? So first step is getting everything on the same side. So I'm going to go ahead and subtract 5 from both sides and add x to both sides. So then it equals 0. So combining all my like terms, I've got x plus x plus x, that would be 3x. And I've got 1 minus 5, which would be negative 4. Okay, so I have everything on the same side. It's in standard form. Then I'm going to factor. So I like doing guess and check factoring for trinomials. So guess and check factoring, what it looks like is the first times the first gives you the first number. So first times first gives me x squared, and the best way to do that probably is x times x. The last times the last gives me my last number. So I know to get a negative 4, one's going to be positive and one's going to be negative. And then my choices are either 4 and 1 or 2 and 2. So then I'm looking at the combination to give me a 3x when I check it. So it's probably going to be the 4 and 1 because 4 minus 1 is 3. Okay? And I just double check that I chose the right order and the right signs for everything. The outer product, that's x times negative 1, is negative x. The inner product, which is 4 times x, is a positive 4x. And outer plus inner should give me my middle number, which it does. Okay, so this is factored correctly. After this point, if two things multiply to give you 0, one of them's got to be 0. So what we're going to do is set each factor equal to 0. We're going to have two little equations, x plus 4 equals 0 and x minus 1 equals 0, and solve our little equations. For the first one, I'll subtract 4 from both sides and get x equals negative 4. From the second one, I will add 1 to both sides and get x is 1. Okay? So I've got two solutions. Sometimes we will get two answers for these and they're both going to work. Sometimes only one of them works and sometimes neither of them works. So I need to check to see if they work or not. And how do I check them? I check them in the original equation. So I'm going to have the square root of 5 minus x. So for negative 4, I'll have 5 minus negative 4. And that should equal x plus 1, so negative 4 plus 1. That's how I'm going to check the first one. For the square root of 5 minus negative 4, 5 minus negative 4, same thing as 5 plus 4, which would be 9. On the other side, negative 4 plus 1 is negative 3. So is the square root of 9 equal to negative 3? No, it equals positive 3. That doesn't work, which means that negative 4 is not really a solution to my original equation. Let's check x is 1. So I'm going to have the square root of 5 minus x, so 5 minus 1. And I'm going to see, does that actually equal x plus 1, so 1 plus 1. Well, 5 minus 1 is 4, so I would have the square root of 4 on the left side. 1 plus 1 is 2. Is the square root of 4 equal to 2? Yes, it does. So x equals 1 is the only answer to this equation. All right, what if I have more than one radical? This one's going to take us some time. Let's see how this one goes. I've got the square root of 2x plus 3 plus the square root of x plus 1 equals 1. And the first thing we should do is get the radical by itself, right? And the thing that you're going to notice is I can't get either one of those by itself, so we're going to go with one of them, okay? I'm just going to get, how about the first one by itself, 2x plus 3, and I'll subtract the square root of x plus 1 from both sides. So I'm getting one of them by itself. To undo the square root, I'm going to square both sides. The squaring and the square rooting are opposite operations. They're going to undo each other. On the other side, keep in mind this is 1 minus the square root of x plus 1 times 1 minus the square root of x plus 1. Okay? We've got to distribute. 1 times 1 is 1. 1 times the negative square root of x plus 1 is negative square root of x plus 1. negative square root of x plus 1 times 1 is another negative square root of x plus 1. The negative square root of x plus 1 times another negative square root of x plus 1 is going to be a positive square root of x plus 1 squared, which is just going to be x plus 1. So just writing you x plus 1 squared like that. Oop, you can't see. That squaring and the square rooting will undo each other, okay? That's where this x plus 1 is coming from, okay? All right, let's see what we can do from here. From here, you're going to notice we still have radicals. Well, the good news is that they are like radicals, so we're only going to have one radical instead of two, okay? So let's go ahead and combine some like terms here so you guys can see a little more clearly what we have. On this side, we have a 1 plus 1, which would be a 2. We still have an x, and the minus square root of x plus 1, and another minus square root of x plus 1 would be minus 2 square root of x plus 1. All right, so let's just get that by itself now. So to get that radical by itself, I'm going to subtract 2 from both sides, and I'm going to subtract x from both sides, and I'll probably have to divide by negative 2 at some point, right? So let's see, that'll be x plus 1 equals negative 2 times the square root of x plus 1. Whew. All right, so then we'll divide both sides by negative 2. Okay? And then we finally have the square root by itself, okay? So the opposite of square rooting is squaring, so I'm going to go ahead and square both sides. When I square this side, keep in mind that x plus 1 squared, that's x plus 1 times x plus 1, okay? So that would be x squared plus x plus 1. I also need to square my negative 2. Negative 2 times negative 2 is a positive 4. On the other side, this one's a little more straightforward because the squaring and the square rooting undo each other, and you're just left with x plus 1. At this point, we finally got rid of all the radicals. Hooray! But we've got a quadratic, and we should probably solve that, okay? One thing that may bother you is that we are all over 4 on this side. So one easy fix is that we could just multiply both sides by 4 so that we don't have 4 in the denominator anymore. Those would undo each other. 4 divided by 4 is 1. Then we'll just be left with an x squared. We'll combine our like terms and get a 2x and have a plus 1 over here. We can distribute the 4 and get 4x plus 4 on the other side. Then we've got another quadratic, so that means that we're solving by factoring. So I need to get everything on the same side first. So I'm going to subtract 4x from both sides, and I'm going to subtract 4 from both sides. So that'll be x squared minus 2x minus 3 equals 0. Then we'll factor. X times x is x squared. To get a negative 3, one's going to be positive, one's going to be negative. It's probably going to be a positive 1 and a negative 3, because negative 3x plus 1x is negative 2x. From this point, we're going to have our two separate equations. X plus 1 equals 0, and x minus 3 equals 0. I'll subtract 1 from both sides and get x is negative 1. I'll add 3 to both sides and get x is 3. We do need to check. So quickly we'll check. If x is negative 1, you're going to get the square root of 2 times negative 1, so that's negative 2, plus 3, plus the square root of x plus 1, so that's negative 1 plus 1. And we're going to see if that equals 1. Negative 2 plus 3 is 1. Negative 1 plus 1 is 0. And does 1 plus 0 equal 1? It does. That is a solution. If we check the x is 3, we will have the square root of 2 times 3, which is 6, plus 3. We'll have the square root of 3 plus 1, which is 4. 6 plus 3 is 9. And you're going to have, is 3 plus 2 equal to 1? No, that equals 5. So that one does not work. So sorry about rushing at the end, but that's how that one ends up. Now it is, oh goodness, we'll do example 3 in another video, okay? So we'll pick up an example 3 in just a moment.